Hello everybody. In this lesson, what we are going to be discussing are how you solve some basic logarithmic or exponential equations. Now we've already seen a little bit of the examples of how these are worked. When we've had to evaluate some simple logs, we kind of just converted them into an exponent and then we'll said, oh, it's going to be equal to this because uh, we are able to much more intuitively figure out what an exponential value is going to be than a log value. Well, here we're going to start seeing some instances where it's not going to be the easiest thing in the world, or it's not going to be so straightforward where we can just say, oh, it's going to be this or it's going to be that. And what we'll have to do is kind of convert from one form of the equation into another in order for us to either evaluate it by hand or evaluate it by saying, oh, we can type that into the calculator instead, it'll give us a number. So just keep in mind that the base of these values for whether it's a log or an exponent, we need it to, the base can't be 1. Now here where it says the base has to be greater than 0, well, we could have bases that are fractions, but we could always convert them into whole numbers. But definitely the base can't be 1 because 1 raised to any number is still just 1. And here are some basic kind of principles that you're going to see is that log of any base of that base, so like if it was log base 5 of 5, well, that just has to equal 1 because if we were to convert that from log to an exponent, well, we would see that, yeah, the exponent is just going to be 1. Same thing in the second one. If I say log base b of 1 is equal to 0, well, yeah, it's going to be equal to 0 because if I say b to the 0 power, that's just 1 because anything to the 0 power is 1. Log base b of b to the x power is the same thing as saying base b of x, or yeah, base b of x is equal to base b of x, and so on. You can read that. But what we're going to be looking at primarily is how are we going to be solving a logarithmic or an exponential equation. Now, pardon me, there are two basic things that we're going to be doing regardless of the format, whether it's a log equation or an exponential equation. Essentially what we want to do is first we need to isolate the base, whether it is like say it's an exponential equation, we need to isolate the base on the left side and the right side so that way we can try to get it to where it would be a common base as an exponent or convert it into an exponential or from an exponential into a log. And it's the same thing with a log is we want to try and isolate the term that has our exponent or that has our variable in it. So the order of operations that we do when we're solving an equation, whereas since we're solving an equation, we're kind of working backwards. We do our order of operations in reverse order is the same thing that you're going to be seeing here. So make sure that you pause the video as you need to get this stuff written down into your notes and refer back to it as needed. So let's take a look at our first example here. Now it's saying to solve this equation for x and write it out to 4 decimal places. Now, typically I would probably just write it out to 3 decimal places, but we'll go ahead and carry out with what it's asking us to do here and write it out to 4. Now, one of the things that we may want to do, that you as a student may want to do, if you don't recognize it, remember the base of a natural log is the number e. So if you want to, before trying to work this out, you could simply say log base e of x is equal to 1/2. If we write it in that way, it might be easier for some of us to say, oh, this is how I convert it. Because remember, log of base e is the same thing as saying the natural log. So here we have a natural log of x is equal to 1/2, which has e as a base, meaning I would say e to the 1/2 power is equal to x when I convert it, because our calculator does have a natural log button, so we could say the natural log of something is, and hit a number and see what is it equal to, but we don't know what the number x is supposed to be. So we're going to be guessing a lot to try and figure out what e is, or I'm sorry, what x is going to be if I just say ln and keep randomly picking numbers to see which one it will equal to 1/2. But if we take it and convert it into an exponent, well, that makes it a lot easier to see, oh, I typed this into the calculator. Now on your calculator, all you're going to do is just find your E button depending on, well, where is it located. On some calculators, you just have to keep hitting the same button 2 or 3 times before the E comes up. On some calculators, you have to say a second function and then hit a particular button to get E on your calculator. But in whatever calculator you're doing, you're going to just hit it in such a way, do your keystrokes to where you get E as a number displayed on your calculator where it just says E, and then raise it to the 1/2 power. And so here we're going to just round it out to 4 decimal places. So E raised to the 1/2 power, which is basically the same thing as saying the square root of E, we would get 1.6487 to be equal to x. Now, again, keep in mind we're rounding that number. We could save whatever that entire long decimal is. We could save that into the calculator and then say the natural log of that number and hit enter, and it will give us 1/2. But at some point we have to round it, so we'll just round it to 4 decimal places, and there we go. That one's pretty straightforward. Convert it from a log to an exponent, type e to the 1/2 power into the calculator, and we're good. We have our answer. Now here, what we started with originally with exponents, when we started to solve the equations of them, is I said, well, if you have an exponential equation, what you need is to convert the bases on the left side and the right side to where they have a common base, and then once you have a common base, set the exponents equal to each other and solve for x like normal. Well, here is an example of where that particular strategy breaks apart, because we have a base of 10 on the left side of the equal sign, and we have a base of 0.024 on the right side. And it's not real, it's not going to be very easy to try and convert 0.024 into a base of 10 like we would have if we said, like, say the right side of the equal sign was 1,000 or 100,000. We could convert that to a base of 10 relatively easily. So because we can't convert the right side of the equal sign into having a common base, well, the fact that the base of the left side is a 10 says, well, let's go ahead and try and convert it into a logarithm and see what we can do there, because the 2 buttons that my calculator is programmed to do is a log base 10 and a log base e. So maybe we can convert this one into a log that'll have a base 10 that we could actually type it into the calculator for. So if we convert this equation from an exponential equation to a log, here we'd say log base 10 of 0.024 will be equal to x. And again, log base 10, that's one that the calculator will do, so we can go ahead and say, hit the log button, because remember, it's not going to say 10 on there. If we just hit the log button and 0.024 when the parentheses that open up on it, well, rounded that out to the 4th decimal place, we're going to get negative 1.6198 to be equal to x. Now again, we're rounding at some point. The decimal keeps going. So you could save the number into your calculator and then go back and say 10 to that whole number saved and hit enter, and it will go to 0.024 exactly. So there's 2 out of the way as far as how we're going to solve a log or an exponential equation when the strategies that we've tried before don't work out for us now. Now here is a new type of equation where we actually have some steps that we have to take rather than just converting it from one form to another and then trying to solve for x. Now here we have an exponential equation. 2 minus 3 times e to the 0.4x power is equal to negative 7. Now in this case, the base of this exponential equation is the number e. And a lot of times, because e is a number, students have a tendency to uh, think that they can divide by, say, 3 and e at the same time, like if we're trying to solve for a variable. And a lot of times students will confuse that. But remember, if we work our order of operations backwards, the exponents are actually going to be the last thing that we worry about. So we have this equation, and in order to start solving the equation for x, in order to get the base with the exponent by itself, the very first thing that we're going to do is to subtract 2 from both sides of the equal sign. Now on the left side, they're opposites and cancel out, and I will have negative 3 times e to the 0.4x power is equal to a negative 9. So the negative 3 is multiplied to the base, and we're trying to isolate the base. So in order to get e by itself, we're going to do the opposite of multiply by negative 3, which would be to divide both sides by negative 3. So on the left side, negative 3 over negative 3 simplifies to be 1. So I have 1 times e, which will just be e to the 0.4x power. And negative 9 divided by negative 3 is a positive 3 on the right-hand side. Now at this point, what we've done is we've isolated the base of the exponent by itself, meaning we have a base of e raised to the 0.4x power being equal to 3. And if we were able to solve this with the normal exponent rules, what we would say is we would try to get a base that is common to the left side and the right side. And the base on the left side is an e, which is an irrational number, and the base on the right side is a 3, which is a prime number. So there's really nothing that we can do to try and get e and 3 to be the same number on both the left side and the right side. So since we cannot convert the bases to have a common base, at this point what we will do is we will convert it from an exponent into a logarithm. So I will say e, not e, trying not to convert it from I'm trying to convert it from an exponent to a logarithm, not the other way around. Okay, so here we would say log base e of 3 is equal to 0.4 times x, or more appropriately, ln of 3 is equal to 0.4x. So now we can, again, and the whole reason why we use e a lot is because, or why e has its own button on the calculator as far as the log is concerned, is because it gets used so much. So at this point, we have the natural log of 3, which we can type into the calculator, is equal to 0.4, let me clean that up, 0.4x. And at this point, because the 0.4 is no longer in the exponent position, we can say, well, that 0.4 is just being multiplied to x, so I can divide both sides by 0.4. And on the right side, they simplify to be 1, so I will have the natural log of 3 divided by 0.4 to be equal to x. And that is something that we can type into our calculator very easily. We can say natural log and hit 3. We'd have to close the parentheses before we hit divide, and then say divide by 0.4. And when we do, we will get rounded to 4 decimal places again, 2.7465 to be equal to x. Now again, we can save that entire number on our calculator, but we're rounding it to have some, we got to stop it somewhere. But we could save that number on our calculator and then type, go back to the original problem, 2 minus 3 times e to the 0.0 or 0.4 power, and then multiply that whole number that we saved in the calculator, hit enter, and it should simplify to be exactly that, -7. Okay, so this is going to be our last example that we look at here, where we're trying to isolate the term that has our variable on it. So that way, at that point, we can say, okay, can I work it out as a log, or do I have to convert it into an exponent in order to try and get my final answer? So we have -4, which is being multiplied to the log of 2x plus 9, and then all of that is equal to 3.6. Now the interesting thing, one thing that you guys as a student need to pay attention to, the base of the log is not expressly written, so it's implied that this is going to be a common log of base 10. So if you want to, you could put the base 10 when you write out the log, but so we're going to treat this just like any other equation, work it backwards as far as our order of operations is concerned in order to isolate the term with our variable. That means since addition and subtraction is usually the last thing according to PEMDAS, that means when we're solving an equation, that's kind of the first thing that we get rid of or work out is the addition or subtraction. So here the 9's cancel each other out, and I would be left with -4 log of 2x is equal to, and 3.6 minus 9 will be a -5.4. Okay, now at this point, the -4 is essentially being multiplied to the log base 10 of 2x. So at this point, -4 log 2x equals -5.4. I just don't want to write everything as one long continuous problem. Let's show what we're doing at each step. So since the -4 is being multiplied to the log, we divide everything by -4, and on the left side, -4 divided by -4 is just 1. So I'm left with log of 2x, and -5.4 divided by -4 will be a positive 1.35. Now, at this point right here, we have isolated the term with our variable as much as we can. So at this point, since we're still trying to figure out what value of x we can plug into that log and say it's equal to 1.35, we could, pick and choose numbers and type them into the calculator and see what we wind up getting. The other thing that we could do is convert it from a log into an exponent and then say, well, can I type that into the calculator a little bit easier, or can I solve for x a little bit more cleanly to see what we should wind up getting? So again, the base of the log is a 10. So when I convert the log into an exponent, I'm going to say 10 to the 1.35 power is equal to 2 times x. And since x is multiplied by the 2, I can divide everything by 2 and say 10 to the 1.35 power divided by 2 will be equal to x. And that is something that we can very easily type into our calculator and say 10 to the 1.35 power divided by 2. Now, some of us might be tempted here to say that this is 5 to the 1.35 power, and that would be an absolute mistake because that would be a violation of order of operations. You would be dividing before you did your exponents, okay? So on your calculators, say 10 to the 1.35 power, hit enter, and then whatever that is, divide it by 2, And here, x rounded to 4 decimal places will be 11.1936. So there is the final solution. So these are some relatively basic equations as far as exponents or logarithms are concerned. If the exponent or the log is already simplified, meaning it's already kind of isolated by itself, then all we really need to do is convert it maybe into from one form to the other, so that way we could uh, get our final solution. The other thing that we might need to do is using our normal rules of opposite operations when it comes to solving for a variable. Uh, Isolate the term that has our variable in it, whether it's a log or an exponent, and then evaluate, do I need to convert it from one form to another to see if we can finally get our final answer for x. So that's pretty much it as far as the basic equations of logs and exponents. So if you have any questions, make sure that you've written them down and bring them to me in class, and look forward to seeing you guys soon. Thanks for watching.